So anybody that watches it later.
Well, then we will go ahead and get started. If you guys have questions during the presentation, feel free to just stop us and go ahead and ask. It's kind of put together as a formal presentation, but we want this to be an informal discussion, and we certainly don't need to wait till the end of these slides to have that discussion. So thank you all for joining us today and to talk about this technical assistance project for St. Mary's. Like I said, as we get started, we can go ahead and do introductions. Maurice, do you want to go ahead and go first with those of you for the city?
Yep, Maurice Cordell, City Manager.
Bob Schindler, Street Supervisor.
Joanna, do you want you all at KDA to do your introductions?
Okay, yeah, I'm Joanna Rolfe. I'm the floodplain mapping coordinator.
Good morning, this is Tara Lansworth. I'm the NFIP coordinator with KDA.
Bill Pace, a floodplain mapping specialist with KDA.
Terry Medley, KDA.
And then I am Joe File with Benish. I'm a project manager and senior water resources engineer with Benish that have been working on this technical assistance project, but I have also worked with St. Mary's previously in Benish's capacity in terms of looking at a project for you all to address the flooding. And then prior to that, at another firm, I also had involvement in this project in terms of doing the floodplain mapping as well. So I've been familiar with this particular issue in St. Mary's for a number of years.
Yep, and I'm Maria Nealand with Benish as well. I've also participated in those floodplain mapping efforts, and then of course this technical assistance project as well. I too am an engineer and project manager.
So we'll go ahead and get started. Maria and I will kind of go back and forth on this a little bit. So just to touch on the project background, and I know you folks at the city know this, so we'll try and keep this pretty brief. But in 2018, the City of St. Mary's initiated a project to determine mitigation options for reducing the flood risk associated with College Creek for the St. Mary's citizens. That was a result of floodplain mapping efforts that had occurred previously by the state of Kansas as a CTP, which is a cooperating technical partner with FEMA. Under the FEMA program, there had been coordination leading up to that time in 2018 in terms of some draft floodplain. I know that the city did a number of reviews, put in a lot of input. The modeling approach even changed at that time to better represent what the flooding looked like in St. Mary's. And there was a fair amount of area that actually came out of the floodplain due to the city's efforts in terms of coordinating with the state, and then in terms of the state making sure that the approach was correct. And so there was a lot of collaborative effort between the Division of Water Resources and the City of St. Mary's that went into the development of those floodplains. In 2018, the project resulted in the recommendation of an upstream detention structure, along with some limited channel improvements on College Creek in order to resolve the flooding. Now, in that 2018 project, there were a number of alternatives that were looked at, anything from upsizing some bridges on the highway and the railroad and a couple other streets in St. Mary's, doing some channel improvements. There were alternatives of levees that were looked at. There were a number of alternatives that were looked at, but the only alternative that really came close to addressing the issues was the detention alternative with some limited channel improvements. And so this shows the cost estimate that was put together for the project in terms of reducing the flood risk for the citizens along College Creek. I will say that there was some additional work done by Benish in that 2018 project that showed some potential additional things that could be done to help enhance the area, to keep some of the mitigation alternatives local and things like that. But at its course, the cost estimate to do the work to construct the dam was 5.7, little over $5.7 million to do this project. When that project was done, this is the flood risk that project was intended to address. There were 68 structures, homes, businesses, some of it commercial, a school that was in the 100-year or the 1% chance floodplain. The assessed property value is roughly about $30.4 million. And in the 500-year or 0.2% chance floodplain, the assessed property value is roughly $38.5 million. We also show an estimate of the population impacted by this flooding. We like to look at this both in population as well as in value, because when we're dealing with homes, we want to make sure that we're looking at this from an equitable standpoint and not necessarily valuing one home, that might be a several $100,000 home differently than a number of other homes. So when we bring it back to population, it just brings that equitable component to it that we try to do with all of our projects as we evaluate this. So I know that last year discussions between St. Mary's and Kansas Department of Agriculture, Division of Water Resources through a community assistance meeting occurred. Actually, it was January of this year. I was thinking that was late last year. There were discussions at that time about, the city had done this project with Benish, but it's pretty expensive. And they were wondering, kind of what else could be done to potentially reduce project costs. There were some other unknown questions about potential cost sharing and funding opportunities. There were some questions about what happens if, whether it's climate change or just other changes occur, what's the potential to construct this project and then end up with another FEMA mapping update in 10 to 15 years? And would that negate the benefits of this project? So there were a number of questions that were brought up, and the discussion was to go ahead and initiate a technical assistance project in order to help answer some of these questions for the city. So the project scope that we've looked at is to evaluate some conceptual engineering enhancements to the study, which could potentially identify some specific cost savings. As part of that, we did look at some additional alternatives, which we'll talk about today. The second task was to do a benefit cost analysis, better define the benefits of the project, evaluate those against the refined costs that were associated with task one, and then ultimately develop a multi-frequency benefit cost analysis, which we'll talk about. We were asked to look at some potential funding alternatives. Now, I will say this wasn't a huge task. We kind of knew going into this that there was no easy answer. If there was, the city would have already known about that. But we have looked at some options that we'll talk about a couple of those today, and our report will actually present some additional possibilities that the city could consider. And then finally, evaluate this question about resilience and future climate change. What is the potential that if the city were to do a project like this and spend this kind of money, that whether it be climate change or whether it be development in the watershed or whatever it may be, what is the potential that a future FEMA mapping project could negate some of these benefits, and what would that look like? So those are the questions that we've set out to answer with this quad project and what the rest of this presentation is going to focus upon today. So conceptual engineering enhancements, these are those things that we wanted to look at in greater detail to try and determine if there were ways to reduce the overall cost of this project. So one of the big things that we noticed is that in the initial analysis, we design that as a rock auxiliary spillway, and the amount of riprap in there in cost was pretty significant. With a 30% contingency, it was actually approaching $1 million of that cost estimate. And so we wanted to evaluate the suitability of a vegetated spillway rather than a rock line spillway, which has the potential to significantly reduce costs. So we use the USDA NRCS sites program to evaluate what we call stability and integrity analysis. And that is just how does the vegetation perform when the spillway flows in terms of sod stripping, in terms of stripping the root structure of the vegetation, which ultimately leads to rills in the spillway itself, which typically we look at that for a 1% chance flood, and then also an integrity analysis, which we actually look at from the design storm perspective of a high hazard dam, which in Kansas is 40% of the probable maximum precipitation, which is an event somewhere between a 500 and 1,000 year event. It's not truly a frequency, but if you wanted to know what kind of rainfall and flow that looks like, it's somewhere between a 500 year and 1,000 year event. So we did that analysis, and what we determined is that for that state design storm for a high hazard dam, there really wasn't any issues with a grass line spillway. So we were able to switch the concept from a rock line spillway to a grass line spillway, which saves quite a bit of money. And then the second thing we wanted to look at is that the dam had a fairly extensive blanket drain system in it. Now, in large part, that is because this was just done at a very initial conceptual level to try and evaluate a number of alternatives. And the next step of this project would have more detailed geotechnical information. So I want to caveat that's all just a little bit of a guess and assumption as to how this blanket drain would actually play out. But we did update the geotechnical models with some geometry enhancements. We actually included a cutoff trench in the model and did it more like the design would be, did some additional modeling on the factors of safety. And what we ultimately determined is that while a blanket drain, based on the limited geotechnical information that we have available now, is needed, we were able to reduce the size and ultimately the cost of the blanket drain to some extent in order to determine a more feasible blanket drain and reduce the overall cost estimate. So this is an updated cost estimate, and there are a number of changes to this that the report will talk about, but the big ones are that in the secondary spillway itself, the riprap, the non-woven geotextile comes out of here, so that was a pretty significant savings. The blanket drain quantities, the filter layer, all that has been reduced. The linear footage of the 4-inch perforated PVC pipe has been reduced. Now, there are some other changes in this. I will point out that the previous cost estimate was an FY24 construction cost estimate, and the growth or inflation rate was a 4% rate. We went back to the initial estimate and we changed it. We extended it one more year to a 2025 cost estimate because we felt like at this point in time, that was more reasonable to present based on where you all are at in your decision-making process. And also, I went ahead and changed that to a 5% inflation rate, just because I think that's a little bit more in line with what we've actually seen with construction materials since that occurred. There were some other changes. I mean, the design engineering fee went down some because the overall cost went down, and it's based on a percentage of those costs themselves. There were some other fees that went down associated with this. And like I say, the report will go through that in detail, but the big ones are the blanket drain and the spillway is the single biggest one. So you see, we were able to reduce the cost estimate here by about $600,000. We wanted to look at this instead of a wet pond. What about a dry detention pond alternative? Now, I'll say up front, the offset of this is we've got to negotiate land acquisition. And so there are some advantages to the landowner in terms of what a wet pond could potentially look like, which makes those negotiations go easier. But we actually do have some costs in here in terms of easement negotiation and acquisition already. We feel like if we go to a more of a dry pond scenario, we can create some little wetlands in the bottom of there. It can still be kind of a wildlife habitat amenity. It looks a little different. It's not a wet pond. It's certainly not a fishing pond, but you could still potentially have walking trails around there. You could do a number of things that could make it sort of a natural amenity and incorporate, benches and some park type features in that. So we feel like it's still reasonable to make this assumption. But in doing this, we're lowering the auxiliary spillway, we're lowering the dam, so we're changing the amount of material that it takes to construct the project. We are not changing the benefits of the project. It still holds back the 1% chance event with only primary spillway flow. It still meets the state of Kansas dam safety criteria. It does substantially lower the stream mitigation costs. And I was pretty careful with this. I feel like it's still a pretty conservative estimate, but instead of having to mitigate the loss of the stream channel for the entire wet area, we're able to leave the stream channel intact. And again, I feel like I've been pretty careful with this, and that's still a fairly high number. It's possible that when we get into this comes down even a little bit more. But as you can see, we were able to lower this by another $800,000 and get the cost estimate down to $4.35 million by switching it to a dry pond. So it definitely seems worthwhile to explore this alternative. We've talked about the fact that it's a high hazard dam. Probably don't want to spend any more time on that. But one other thing we wanted to look at is, what about a 50-year detention? What if we reduce the benefits from a 1% chance flooding to a 50-year flooding? What would that look like? What would be the impacts to the downstream flooding condition? How would that impact flood insurance? And so we wanted to look at that as well, just to give another basis for comparison. So obviously, when we do the 1% chance detention along with the channel improvements, we get the water to stay within channel. There are no structures impacted. If we do those same channel improvements but change the reservoir to a 50-year detention reservoir, where then you get auxiliary spillway flow, then we get a few homes that creep back into the floodplain and have those potential flood insurance requirements. We also have additional flooding that kind of bulges out. We get some additional street flooding. So you can see there's some additional flooding there, but it is fairly minimal. There are a few structures that would have NFIP insurance requirements associated with federally backed mortgages, but it's a fairly low number. So still probably worth the consideration with the city. And see, there are 7 buildings in the floodplain, and that's what the peak discharge from the reservoir itself would be, is 420 CFS. So again, we looked at the wet pond option. It goes down to 4.5 million. So again, the savings on that compared to the wet pond 100-year are more significant. Obviously, it's not as significant as the dry pond improvements because it still is a wet pond. It gives a different kind of amenity to the landowner. It could make negotiations easier as far as easements, but it is the alternative is it's only providing 50-year protection, and there are still 7 homes in the floodplain. And then we looked at the same thing for a dry pond, and you can see it's a little bit lower than the 100-year dry pond, but really not significantly when we start to lose that level of protection. So just a fourth alternative that we looked at is a 50-year dry detention dam alternative, and the same types of factors with mitigation apply, and the same type of discussions in terms of easement negotiations apply. So with that, I'm going to turn it over to Maria and let you talk about benefit costs, Maria, and some of the additional alternatives we looked at.
Great. So Joe went into some detail about the refined costs. We'll start by talking about the determination of the benefits associated with these projects. So go to the next slide, Joe. Okay, so we utilized a number of pieces of data for determining the benefits associated with each of these projects. And We've got those listed here as far as parcel data, building footprints. We did use assessed property values for determining the damage estimates. We also utilized survey data that was available for determining lowest adjacent grade, and whether certain buildings that were kind of on the edge of being in or out of those flooded areas were actually impacted or not based on the water surface elevations and that surveyed information. Of course, we use the available LiDAR information or that ground surface elevation data that we have available, the water surface elevation and depth grids from all of the different modeling scenarios that we ran. And then for determining the population impacts, we utilize the census block data and a number of GIS processes with those different pieces of data to determine, if there were multiple buildings on a parcel, how were those assessed property values separated out? How was the population for each census block separated out for the different parcels and different habitable structures? Ultimately, we utilized all that information to help us determine our annualized damages and our population impacted, which we'll discuss more in the next couple of slides. And we'll go into a lot more detail in the report as well as to how all of this information was utilized for determining the benefits. We'll be talking about this more later in the presentation, but we wanted to go ahead and mention it now because we talk about it a few times in our benefit cost analyses and separate out a couple structures that we classified as high dollar value structures. They're the 4 large buildings that are hatched in the image shown there. And as Joe mentioned before, the total assessed value for all of the buildings within that 1% annual chance or 100-year floodplain is about $30.4 million. However, those 4 structures identified total about $18.3 million. So over half of the estimated dollar value impacts are with those 4 structures alone. So that's certainly something that we should be mindful of as we go forward. For determining the damage estimates, we utilized a depth and damage curve that's actually defined by the U.S. Army Corps of Engineers. It's their HAZUS curve. And this just shows kind of 2 different situations. The lower curve, the gray one, represents damage associated to a 1-story building that doesn't have a basement. And the top curve represents a building that does include a basement. And so the damages are just a little bit higher for those buildings with basements. We were able to pull basement information from the parcel information in large part to come up with some more accurate numbers there. And this chart shows kind of the way that the annualized damages are generated. And so we utilize the damage information for a variety of different storm frequencies from the 2-year all the way up to the 500-year. And you can see here that we've got the damage estimates calculated for each of those flood frequencies. And then ultimately what this calculation does is it determines the expected annual damage associated with a flood event for that particular stream in any given year, basically the flooding on a probability of occurrence basis and the associated damages. So this is an example of the existing conditions when all of the buildings are included. And this graph here shows the different scenarios. So we've got the 2 different scenarios for existing conditions, all the buildings included, and then those 4 large buildings excluded. As Joe mentioned, whether we have a wet or a dry detention pond, the 100-year damages or benefits are essentially the same because the releases from those ponds would essentially be the same. So we've got the expected damages for the 100-year detention alternative and the 50-year detention alternative. And then we utilize the benefits and the costs to determine a benefit cost ratio. And we did this analysis using a 50-year period, a 50-year return period. And we utilized the OMB A94 nominal discount rate published in December of 2022 by the Office of Economic Policy, which was 4.2%. And we also wanted to mention that we incorporated a number of operations and maintenance costs within each detention dam scenario, capturing costs such as administration, inspection, operation, maintenance. We also included some replacement costs. We utilized a $50,000 replacement cost every 10 years. So we've captured those operations and maintenance costs within this analysis as well. And this table shows the eight different scenarios that we've looked at as part of this, because we've got the 100-year wet detention option, 100-year dry detention option, and then, of course, the 50-year wet and detention options. And then, as I mentioned earlier, we're showing a benefit cost ratio with all of the buildings included, and then also with those 4 large buildings excluded. We felt like that was important information to kind of understand those differences and how those large buildings should be looked at, and potentially whether floodproofing or other considerations should be made for those buildings because of the impact they have on the benefit cost ratio. As we mentioned before, to kind of look at these benefits from an equitable standpoint, we did also do an average annualized impacted population estimate using a very similar methodology. But here we're looking at the impacted population, or the number of residents based on the analysis that we did that would be impacted from each of these different scenarios. And we've got a graph or a table here on the right that shows the different situations and how obviously the numbers will go down with our mitigation alternatives. Okay, and we also wanted to go through some additional alternatives that were considered as part of this analysis. So, as we mentioned before, those 4 large buildings make up a large dollar value, or a large portion of the damages. The far south building is the St. Mary's Grade School, valued at about $7.3 million. North of that is St. Mary's Manor and Community Health Center, close to $2 million. And then the 2 buildings on the north side of town are from St. Mary's College. One is $4.9 million, one is $4.2 million. So certainly something that could be considered as flood-proofing those 4 buildings, which would clearly impact the benefit cost analysis. We also wanted to look at opportunities for different mitigation projects upstream. We've talked about the detention dam alternatives and even going down to a 50-year detention dam, but what about some other type of mitigation alternative that could be more of like a wetland scenario, some kind of offline situation that would still reduce the overall discharges, but not to the extent of a full detention pond. So this graph here just shows kind of the different releases that we looked at as far as total discharges. That would be slower releases over time. Okay, so the left image, let's see, did you skip ahead, Joe? Was thinking there was one that was a 150. Oh, no, I guess not. Okay, so the detention dam alternative is about 150 CFS discharge. And here we've got an option that's 350 and 450 shown here. And so with larger releases, as you would expect, additional homes and buildings come back into the floodplain. And so here we're showing 18 buildings back into the floodplain from 350 CFS discharge, 29 for 450 CFS discharge. I guess we had those two slides flip-flopped there. So here are the 150, as you could see, with no buildings impacted, and then the 250 with 4 buildings impacted. And then we should have another slide with some larger events there. So 550 has 4 buildings impacted, and then this 1540 CFS is existing conditions with 66 buildings impacted. And really what we're seeing is not terribly surprising as we increase the discharges, even just a little bit, going from 150 to 350. We're adding quite a few buildings back into the floodplain. As we do that, our benefit costs certainly go down, and we're getting kind of diminished returns for those different mitigation projects. We also took another look at a potential diversion channel going from College Creek to the east, which would basically be located between the railroad and the highway, divert water from College Creek over to the east, then back down south to kind of some open space. Ultimately, this was determined to be a non-feasible option because there's just not a lot of space to put in a diversion channel in that particular location. It would also require agreements with the railroad and KDOT because we would be in the right of way there. And ultimately, it would just be a pretty difficult type of project to move forward. Not a very feasible option there. We also just looked at buyout opportunities, or at least something that should be mentioned. As we discussed, the total assessed property value within that 100-year floodplain is $30.4 million, so a pretty sizable amount. 12.1 million is the assessed property value for all of the buildings, excluding those 4 large ones, which is still a pretty sizable dollar value for buyout opportunities.
Okay, so you talked about the benefits of those projects, some additional alternatives we looked at. I kind of want to switch now to project resiliency. This is kind of that climate change component of things. Essentially tries to get to the question, what happens if in the future the discharges, the runoff, the rainfall, any of those things go back up? So there are a number of publications out there on climate change, and we looked at a lot of stuff. And I will point out this was a fairly small task within our contract to look at, but we just wanted to get a sense of things. So there are some future land use data sets out there. I'm not going to sit here and suggest to those of you from the city of St. Mary's on the call that certainly know kind of what your future planning discussions have been. I'm not going to try and convince you that this is accurate or not. But when you're talking about climate change, you're talking about a lot of theoretical information. And we kind of just wanted to give a sense of some of that theoretical information that's out there. So not only are there considerations associated with how weather patterns change, how rainfall amounts change, how rainfall intensities change, but there is also information out there in terms of how future population shifts may occur and what that might look like in terms of runoff. And this is just intended to be one of those examples. There are a lot of publications out there. There's nothing that's real specific to Kansas right now, so we kind of have to look to other areas and extrapolate. Here you can see that of some studies that have been done on the Boston area, the Houston area, and the Chicago area. But essentially, what you're seeing is increases in the range of anywhere between 15, even 10 or less, and up to approaching 50%. So I just will point out again that there is some information out there by some climate experts that make the assumption that over time these are the shifts that will occur. You can see there's a shift to 2053. You can see that there's a shift from all the way to 2100 again as well. And again, these are just predictions, but there are a lot of climate models out there. And I'm not gonna pretend to understand a lot of that, nor will I be able to answer a lot of questions at the end of this. But one thing I do want to point out that's being worked on is NOAA is where we get a lot of our rainfall information. And right now we use what's called Atlas 14 for our rainfall totals for all of the different frequencies. So if we're looking at a 100-year event or a 500-year event or a 10-year event, that's where we get a lot of that information. They are working on some new publications as we speak, and they have a number of areas in pilot with a plan to roll this all out in the next few years, where future assessments will be made, first based on actual statistics of what's happening at those rainfall gauges, in terms of rainfall depths, and also rainfall intensities. But then they're going to add a second component or a volume 2 to it that incorporates climate projection adjustment factors, which at some point in time likely will become the standard. So is it likely 10 to 15 years from now that there will be additional requirements to incorporate climate projection factors? And the answer is yes. And what is that going to look like? The answer is right now, there is nobody that knows exactly what that's going to look like. But based on the data that we had looked at, the best thing we could do is figure we would show you what happens if the rainfall and runoff depths for a 100-year or the 1% annual chance frequency increase by 10%, 20%, and 30%, and look at what that might look like in terms of how this project could be impacted by those changes in the future. So on the left of these next 3 slides, you're going to see, if we don't do any mitigation, what those changes might look like. And just to talk about the baseline, I think it was 68 structures are currently impacted by the 1% chance flooding event. So if we have a 10% increase that's due to climate change, population growth, changes that occur in the watershed, whatever those reasons may be, if we have a 10% increase, then we go from 68 to 87 impacted structures. Now, on the right, we show with our mitigation options. So obviously, with no increase at the baseline for the 100-year solution, we've got all the flows in channel. With a 10% increase, this is what it looks like, and we bring 8 structures back into the floodplain. With a 20% increase, we go to 96 structures impacted if we do nothing. And with the proposed alternative, we go to 27 structures that would be now impacted with that proposed solution. So I guess the clear trend here is going to be that we will not have a solution that prevents flooding for a 1% chance frequency if all of the predicted changes and factors were to occur. However, we still have a pretty significant set of benefits with a 20% increase where, we're impacting an assessed property value of almost 37 million versus if we do the improvements, we're still down at around 4 million. And finally, with a 30% increase, you see the same type of thing. We're up to 109 structures impacted, 39 million of impacts, and then with the solution that's being proposed, we're at 16.2 million. Unfortunately, there's nothing we can do if the city were to say, we want to do this, but we want to build in climate change. What's the number that it needs to be? There's nobody that's going to be able to tell you what that perfect number is going to be to keep people out of the 1% chance flooding event. We could do some sensitivity analysis. We could potentially look at, where that sweet spot is in terms of benefits versus impacts. But to say black and white that these structures would or would not have to purchase flood insurance if they had a federally backed mortgage, that's not something that we can do. Frankly, that's not something that anybody can do. So finally, I wanted to talk just a little bit about potential funding. What I will say is that there are a number of funding programs out there. All of them have different strings. There are none of them that are guarantees, and none of them are 100%. They all have certain amount of cost share associated with them. There are a number of FEMA programs such as BRIC, FMA, HMGP. There are some other funds that are available out there for flood reduction, flood damage reduction projects. There are a number of authority programs. There's a number of things out there, but all of them have application requirements. All of them are very competitive. All of them may take some additional work to apply, and none of them are going to happen fast. So, and in some of these cases, there are some additional costs with doing a project like this. Doing the same project might cost more to do it with a federal program because it might add in extra layers of inspection requirements, reporting requirements, and sometimes contractors that understand that simply bid higher to do the same type of projects because they're tied to a higher number of things that they have to do in order to comply with those, particular program requirements. So that all has to be considered. We ran this project through a funding tool that the Kansas Department of Agriculture Division of Water Resources developed as part of a previous technical assistance project to come up with alternatives. And what I'll say is all of this will be included within an appendix in the report. Again, there may be some of these that you want to try and pursue. But I want to caution that there is nothing out here. There's no silver bullet. There's no perfect project. There's nothing I can sit here to do today and say, hey, if you apply for this project, I think you've got at least a 75% chance of getting this. They're all competitive. If you're interested in this, we can talk to you more about it. Tara sits on a committee where she's fairly engaged in some of these programs. She can talk to you more about them, some of the ins and the outs. She's actually done some application reviews on some of these. So we can talk more about it if you're interested. But for this purpose, we just kind of wanted to give some ideas and what the requirements are. So with those, every one of the alternatives that come out of this tool, there's a section that talks about the purpose of the program, the eligibility requirements, the funding levels. They talk about the cost shares. They talk about the period of performance, the application period, the benefit cost requirements, the environmental reviews, etc. So this information that you're seeing here on this HMGP example will come, you'll see a sheet like this in the report on a number of these projects that will kind of help explain what the funding level is, and again, how things are prioritized, et cetera. So this will be included in the report for every one of these, and this is just an example of what's included for HMGP. So I just wanted to talk about a couple of them that come to the top of the list. And Maurice, we've talked a little bit about BRIC before, and Tara is actually a great resource for you if you want to talk more about BRIC. It is a grant funding type program. It comes out of the tool. It's very competitive. There is a 25% cost share associated with it. Your project does fit within the realm of BRIC type projects. The notice of intent would be submitted to the Kansas Department of Emergency Management. If it's accepted at its first run, there may be some additional requirements associated with it. Again, it's not going to be something that's fast. It's going to require some work. It may actually require, while we've done a lot of work on the benefit cost, each one of these programs requires benefit cost to be evaluated a little bit differently. And we tried to do it in a way that is as broad-based as it can be, that kind of gives us an idea of what that's going to look like for all of these programs. But you may have to do additional work on benefit costs. There may be some additional engineering and or GIS requirements. There's certainly going to be some application requirements that have to be filled out in order to apply for these. But a lot of the work is done. The bulk of the work is done to apply for these grants. You've got most everything you need, but that's not to say that you can just plug it in. There may be some formatting requirements, or there may be some additional look. So there could be some additional costs applying for these programs if you were to do that. Another one is HMGP. Again, Hazard Mitigation Grant Program from FEMA. Again, a lot of this, there's more money available following disasters. Sometimes there's not a lot of funding that's available right now. Again, similar cost share requirements. And all these, there's going to be some level of cost requirements, at least 20%. Sometimes it goes up to 30%, et cetera. So just kind of wanted to give you a flavor of that. There's more information in there. And certainly if you have follow-up questions on specific ones of these, once you get the report, I mean, we can help answer those questions on a specific program. But hopefully we've given you a lot of information on each one of those to kind of take a look at, digest, and see if it makes sense for the city of St. Mary's. So with that, our recommendation is to move forward with a mitigation project that incorporates a 100-year detention dam. I still think that gives you the most protection right now. The terms of the costs compared to the additional costs compared to the 50-year alternatives are fairly minimal in the grand scheme of things. I know when we're talking about several $100,000 extra, that's not minimal, but the additional benefits you get coming up with a solution that initially has the ability to get everybody out of the 1% chance floodplain and eliminates the requirements for mandatory flood insurance, reduces the rates associated with those that would like to go ahead and purchase flood insurance. That would be done at a reduced rate because of these projects, because ultimately there is no solution that's going to protect these people from all flooding events. All we can do is look at projects that reduce the risk and have a certain standard. The dry dam has the highest benefit cost ratio. I think you saw that the costs on the dry dams are significantly less than the wet dams. So it gives the same amount of benefits as the wet ponds, but it is much more cost effective. The only trade-off there, it could make that easement acquisition a little bit more difficult, but we believe that there are amenities that could be put in there fairly cost effectively, such as some wetland areas, such as some nature trails that could allow for the usage of this area. It's certainly the more environmentally friendly option, as it's having less impact on the overall stream channel. The only other thing I would say is that the other alternative, if these projects of these dams become too great, is, you could consider, just from a pure economic standpoint, look at what it would take to flood-proof those buildings. Maybe that's looked at through the lens of the city. Maybe this is information that's provided to those. Obviously, two of those are associated with the St. Mary's College. One of those is associated with the school district, and then one of them is associated with that what is it, Maria? That fourth one?
The hospital?
The manor,
The
St.
manor.
Mary's Manor.
Yeah, St. Mary's Manor. And obviously, I'm assuming that's a private entity. But so you could look at flood proofing those, whether that's a city project or whether those, but obviously that has a significant impact on the economics. It also, if that were to be done, and looking at the costs of that, the structural costs of what that would take, it might take removing some mechanical, some HVAC. That would be a very specific building by building assessment, and really not something that we were able to do within the scope of this project. But it is something that could be looked at just purely from an economic analysis. It doesn't do anything for the homeowners, but if you're able to remove those four buildings, then that's, and I say remove, that's not a true statement. If you're able to do some level of flood proofing, to where if that 1% chance, or even that 0.2% chance, that 500-year event occurs, then if you're able to reduce those impacts, then you can have a substantial reduction on the overall economic impacts of those flooding events. So with that, here's all of our contact information. I think all of us are on the call with the exception of Cheyenne, but here's all of our contact information. If you have questions, obviously we're going to talk about questions here in a little bit, but After this is over, we will put together the report. We will get it to you to review. We will give it to you in a review format first and foremost. Try and address questions to the best of our ability and comments. And then obviously we'll be finalizing this report here within the next few weeks. So I would like to think we'll have you a draft report, hopefully to KDA to take a look at by the end of probably by the beginning of next week. And then depending on their comments and anything that they want us to address, hopefully have it to the city within about 2 weeks to take a look at. And then, like I say, we'll do our best to address comments and concerns that you have and try and finalize the thing. So with that, I think we're going to go ahead and shut off the recording, and then we'll just open it up for questions and discussions.
Sounds good.